The Interstellar Race. Who will reach Alpha Centauri first? Can you imagine what the spaceships of the future will be like? Imagine that spaceships will use nuclear energy as fuel in the future. Would those spacecraft be fast enough to reach the closest star to the Sun? And if so, who will go aboard those spaceships? Who would be the first to reach Alpha Centauri? Keep watching until the end of this video to find out. Currently, spaceships, even humanity's most advanced and powerful, have many problems getting out of the solar system. This is mainly due to two factors. The first is that the universe is vast. It is immense, and the distance that separates all celestial bodies are so enormous that they cannot be measured in kilometers but rather in astronomical units and light years. An astronomical unit is the average distance between the Sun and Earth, equivalent to approximately 92.96 million miles. At the same time, a light year is the distance that light travels in 1 year and is equivalent to 9.461 trillion kilometers. For distances within our solar system, astronomical units are used. Still, once we get out into interstellar space, which is the space between the stars and the galaxy, we must start using light years, since the distances between stars are measured by billions of kilometers. The problem of going out. To date, no human-created spacecraft has managed to leave the solar system. The two spacecraft that have gone the farthest have been the Voyager 1 and 2 space exploration probes, which have managed to reach the farthest limits of the solar system, passing through an area called the heliopause, which is more than 14.1 billion miles from Earth, going at a speed of more than 38,000 miles per hour. However, even though the Voyager probes have gone incredibly far, they have not yet left the solar system. As astronomers define that the solar system ends in the Oort cloud, which is a spherical region full of comets, asteroids, and other icy bodies that cover the entire solar system and are almost a light year from the Sun. It is estimated that at the speed at which the Voyager 1 and 2 probes are moving, it will take more than 25,000 years to leave the solar system completely, and only then will they begin their journey towards the stars. 25,000 years. That's a long time. But why will the Voyagers take so long to leave the solar system if they travel over 38,000 miles per hour? As we already mentioned, the reason is that outer space is huge. Even light, the fastest thing in the universe, takes a long time to travel those distances. Modern technology does not allow us to reach speeds high enough to reach the stars in a single human lifetime. Even visiting the solar system's planets takes several years. The only way we can shorten the travel time from one planet to another is with the help of a gravity assist maneuver, a method used to accelerate spaceships using the planet's gravity. Remember that gravity can be represented as a force that makes objects with mass pull everything towards them. But this force can be counteracted with speed. So if an object is moving fast enough, it doesn't matter if it gets closer to a massive object like Jupiter if it has enough speed. It can break out of its gravitational pull. Thanks to this maneuver, we can deliberately direct spaceships to the vicinity of the planets so that they can accelerate them with their gravity and acquire higher speeds to reach more distant places in less time. However, this maneuver has a limit, and that limit is time. To accelerate the ships enough, they must go through the most massive planets, specifically Jupiter and Saturn. But this can only be done once or twice maximum, since the ship must orbit the Sun repeatedly, and this takes many years. So if the fuel in the spacecraft or the lifetime of the instruments and tools on board is limited, we can't waste their lifetime spinning around the Sun trying to speed them up. In these cases, we must use new technologies to acquire higher speeds in less time. Technologies that already exist. In past videos, we have talked about the different technologies that could exist in the future to travel to Alpha Centauri. However, most of them remain in speculation as they do not exist yet. But among all these technologies, there are some that in fact already exist, and that could be the ones that are used to reach Alpha Centauri. But what are they? And who would go aboard those spaceships? First, we must consider that an ideal trip to Alpha Centauri should last less than human life, less than 60 years, since if the trip lasts longer than that, the astronauts who will go will never return. To achieve this, it is necessary to reach speeds close to those of light. Light has a speed of approximately 300,000 kilometers per second, and with that speed, it would take us 4.3 years to reach Alpha Centauri. But if we manage to build a spaceship capable of reaching at least 1/10 of the speed of light, that is to say 30,000 kilometers per second, we would manage to reach Alpha Centauri in just 43 years. But we must not forget that this trip would only be one way. To return to Earth, we would need another 43 years. The round trip would last 86 years. Considering that an astronaut on average is between 35 and 45 years old, the astronauts who make the trip would have to live more than 120 years to return to Earth alive. This is not a viable option, as humans rarely live past 100 years. So how could we make astronauts who go to Alpha Centauri come back alive? The solution may be right before our eyes, thanks to a concept called time dilation. Temporary dilation. Time dilation is a phenomenon that arises from Einstein's theory of relativity. In simple terms, it means that time can pass slower or faster depending on the speed and gravity in which you find yourself. If you were to travel at extremely high speed or approach a massive object, such as a black hole, you would experience time dilation. This can significantly impact space travel, especially when reaching speeds close to the speed of light, like the ones we proposed for the trip to Alpha Centauri. For example, if a spacecraft traveled at extremely high speeds, time aboard the spacecraft would slow down compared to time on Earth. This means that the astronauts in the spacecraft would experience slower time relative to people on Earth. On a trip to Alpha Centauri with relativistic speeds for the astronauts aboard the spacecraft, it would take a few months or maybe a couple of years, but for people on Earth, it would take whole decades. Although the astronauts will not age as much and will be able to return to Earth, it is likely that by the time they return, all their loved ones will no longer be here to receive them, because although for the astronauts the elapsed time was a couple of years, on Earth the time was almost a century. Unfortunately, traveling to other stars implies leaving everything behind. Those who venture on this journey must pay the highest price, and that price will never be to see their loved ones again. Before moving on, don't forget to subscribe to our channel if you haven't already. Make sure to hit the notification bell so you don't miss out on our daily videos. What technology will be chosen? That said, considering the trip to Alpha Centauri will take more than 80 years, what technology would be chosen to do it? Well, let's see the options. 1. Nuclear fusion propulsion. 2. Pulse nuclear propulsion. 3. Propulsion by a solar sail. 4. Laser propulsion. 1. Nuclear fusion propulsion. Nuclear fusion propulsion is a space propulsion concept based on the use of energy generated by controlled nuclear fusion. Instead of using chemical reactions as in conventional chemical rockets, nuclear fusion propulsion seeks to harness the immense amount of energy released when light nuclei, such as those of isotopes of hydrogen, are fused to form heavier nuclei. The goal is to generate a scorching and dense plasma through magnetic or inertial confinement, where hydrogen nuclei can fuse to release a large amount of energy in the form of radiation and charged particles. This released energy can be channeled to generate thrust and propel a spacecraft. Nuclear fusion propulsion offers the possibility of a much more efficient and powerful energy source than current propulsion methods, thanks to which relativistic speeds could be reached in a relatively short time. 2. Nuclear pulse propulsion. Pulse nuclear propulsion, also known as pulsed nuclear explosion nuclear propulsion, is a space propulsion concept that involves using controlled nuclear explosions to generate impulses and propel a spacecraft. The idea is to detonate nuclear explosions behind a spacecraft to create a thrust that propels it forward. These nuclear explosions, often powered by fusion bombs, would generate a large amount of energy in the form of radiation and plasma, which would expand and be directed into the space behind the ship, thus causing the ship to propel itself in the opposite direction, reaching a fraction of the speed of light in just a couple of years. When nuclear explosions occur in rapid succession, they generate a series of shock waves that can be captured and harnessed to generate momentum in the spacecraft. This boost would be achieved using a shield or a thrusting device that would absorb and redirect the energy generated by nuclear explosions. 3. Solar sail propulsion. Solar sail propulsion is a theoretical space propulsion method based on harnessing the pressure of solar radiation to propel a spacecraft. It uses a very light and large sail or reflector known as a solar sail, which reflects solar radiation. Sunlight hitting the solar sail exerts pressure due to momentum exchange with photons. Although the pressure from sunlight is minimal, the thrust buildup becomes significant as the spacecraft accelerates. However, this type of propulsion presents a major problem. Did you already realize which one? That's right. There's not enough sunlight in interstellar space, so this technology might not be the right one for interstellar travel. Or is it? Before we move on to the laser propulsion, be sure to stay tuned afterwards if you haven't seen our earlier release on solar sail propulsion, the future of space travel. 4. Laser propulsion. Laser propulsion is a space propulsion concept that relies on using a high-powered laser beam to propel a spacecraft. The idea is to use a ground-based laser or an array of orbiting lasers to send a concentrated light beam towards a space sail or spacecraft-mounted reflector. When the laser beam hits the space sail, it absorbs the radiation and uses it to generate forward momentum. The light pressure generated by the laser can gradually accelerate the spacecraft to very high speeds without the need to refuel on board. In other words, this technology could be mixed with the previous method and create the necessary momentum to reach the desired speed. This is the most promising technology for making the first interstellar trip to Alpha Centauri. Most likely, the first trip to Alpha Centauri will not be made with a single type of propulsion, but with a mixture of all of the above. A spacecraft will likely be built that best implements all the technologies above. However, all of these have a big problem, and it is that although these technologies already exist, they have not yet been tested. There is still no spacecraft that is propelled with a solar sail or with lasers, but little by little, all these technologies are beginning to be tested. And the first interstellar trip to Alpha Centauri will certainly have at least one of these. Who will go aboard the spaceship? As for the people who will undertake the first interstellar journey, we can't say who they will be because we don't know. Likely these people have not yet been born, or maybe they are one of the people who are watching this video. It's not possible to predict it, but what we can know is that these people will be the bravest members of the human race, the ones who will bet everything to satisfy humanity's insatiable spirit of exploration and the tireless search for the truth. They will be the ones who leave everything behind to become the first interstellar beings. Those who make this courageous journey will say goodbye to all of their loved ones. Upon their return, they will not have friends or relatives to receive them, but they will not need them because they will have the support of all of humanity. And you? Do you think that any of those watching this video could be that crew member who will travel on board the first interstellar journey?
T-minus 6, 5, 4, 3, 2, 1.
Robert H. Goddard couldn't believe his eyes. His rocket finally went up to an altitude of 41 feet in 2.5 seconds and landed 184 feet away. It was March 16, 1926, a date that changed the world forever. Today, the Goddard Rocket Launching Site National Historic Landmark commemorates the site of the world's first successful liquid-fueled rocket. You can find it in Auburn, Massachusetts. The original launch site is indicated by a granite marker. Almost 97 years have passed by since that day, and nowadays the majority of unmanned rockets that deliver spacecraft and satellites to Earth orbit or on to interplanetary expeditions use a liquid propulsion system, just like Goddard's rocket. But humans like to look further, and ever since that day they have been thinking of ever better solutions. For instance, we want to go outside the solar system and reach other stars. To do this, we might need solar sails. As Goddard himself said, The dream of yesterday is the hope of today and the reality of tomorrow. Let's explore together the reality of tomorrow, learning about solar sails and how they work. Would consist of a reflective sheet. The photons would bounce off this surface and impart momentum to it, just like a collision of two billiard balls. As billions of light particles hit the sheet, they push the sail strongly enough to move a spacecraft. Over time, the solar particles can keep pushing a spacecraft faster and faster, allowing it to attain very high speeds. To work properly, these sheets must be something like 40 to 100 times thinner than a sheet of paper, and they can be as large as football fields. So, what kind of material should be used for this purpose? And what kind of design? Near-term sails likely will use aluminized mylar. It is a strong and thin polyester film. Or maybe they will use CP1, a space-rated insulating material. Both of them are proven materials previously flown in space. In the future, more robust sails could be made out of carbon fibers. The latter offers the most durability but can be more expensive to produce. Each of these materials has its own strengths and weaknesses, and the type of sail to be used will depend on the mission. The design of the sail is also crucial to its success, as it must be lightweight and strong enough to withstand the harshness of space. There are three basic types of near-term solar sail designs: the three-axis stabilized square solar sail system, the helio-gyro sails, and the spinning disc sails. The first one looks quite much like a kite and uses a rigid structure to extend and suspend the sail material in space to catch the sunlight. The helio-gyro design was initially considered by the Jet Propulsion Laboratory for a mission to Halley's Comet. The sail consists of several very long vanes extending from a central hub. The vanes are deployed from rollers by spinning the craft. The centrifugal force pulls the sail outwards, unrolling them. The vehicle continues to spin in order to keep the vanes tight. It steers by tilting the vanes, which redirects the solar pressure. The helio-gyro is an attractive option because it requires minimal fuel and it is highly efficient. It is capable of accelerating to high speeds, and it is maneuverable, making it suitable for interplanetary exploration. Its lightweight design also makes it attractive for larger mission designs. Despite these advantages, the design has several limitations, most notably its complexity, lack of redundancy, and lack of qualification for use in deep space. The spinning disc sail has a number of advantages. This configuration also uses rotation as a means of tension across the film, similar to the helio-gyro, though the spinning disc has a continuous sail film. A distinctive feature of the spinning disc is that it can also passively deploy by using rotation. Anyway, that sunlight exerts a small amount of pressure as photons bounce off a reflective surface. We knew since the early work of James Clerk Maxwell, but to be sure we needed some experiments. In 1960, NASA sent a metallized balloon satellite called Echo 1 to space. It was the first passive communication satellite experiment. Scientists wanted to make sure we could use satellites as a means of communication from one location on Earth to another. Among other things, the spacecraft was useful in the calculation of solar pressure, due to its large area-to-mass ratio. Photon pressure played orbital soccer with the Echo 1 thin film balloon in orbit, and the shards were flung far and wide by sunlight. Later on in the 70s, JPL led a project to try the first solar sail flight. Halley's Comet was to make its closest approach to Earth in 1986, and NASA conceived the exciting idea of propelling a probe via solar sail to rendezvous with the comet. Eventually, the project was scrapped. A lot of other experiments from all over the world, going from Russia to Japan to America and Europe, have been done. By the end of the 20th century, however, no sail had been deployed in space. Many automatic probes, starting with Mariner 10, did use the mechanical effect of sunlight on their solar panels to change their orientation, but this method was never applied to propel a ship. The Russian Znamya 2 did reach orbit in 1993, but it was used not to obtain thrust from light, but as an experiment on illuminating the Earth's surface with an orbital mirror. And even this experiment ended in nothing. The Planetary Society's first crowd-funded solar sail mission, Cosmos 1, was also launched in 2005, but it failed to reach orbit. Finally, in 2010, Japan's Ikaros spacecraft was the first spacecraft to use controlled solar sailing as its sole method of propulsion. It was a kite solar sail that flew by Venus at a distance of 80,800 kilometers, successfully completing its planned mission. On November 30, 2012, JAXA announced that Ikaros had been recognized by Guinness World Records as the first solar sail spacecraft between planets, and that its two separated cameras, DCAM-1 and DCAM-2, had been recognized as the smallest size of the spacecraft flying between planets. Solar sail technology makes it possible to explore distant stars and planets in a way that was previously unimaginable. This technology could allow spacecraft to reach the outer regions of our solar system and beyond, opening up possibilities for future exploration. Solar sail propulsion could also enable us to explore the universe in a new way. By harnessing the power of the sun, a solar sail spacecraft could slowly and consistently accelerate, allowing us to explore distant stars in just a few years. Actually, scientists had an idea. Knowing that solar light can accelerate our lightweight sail, what about trying to build a whole system of light beamers and light sails in order to reach other worlds? This would allow space travel at a significant fraction of light speed. The brilliant idea is to build a ground-based light beamer, pushing ultralight nanocrafts, miniature space probes attached to light sails, to speeds of up to 100 million miles an hour. Such a system would allow a flyby mission to reach Proxima Centauri in just over 20 years from launch. This is amazing. A project like this already exists. It's called Starshot. Using advanced miniaturization, sensors, and communication systems, this spacecraft will travel more than 20 years to reach its destination. However, given the little size of the light sails and their high speed, there are a lot of unsolved problems and questions to be answered. For instance, how are we going to navigate a so small sail at this speed in interstellar space? What kind of material should we use in order for the sail not to burn or break apart? We would need a material that is ultralight, extremely reflective, and almost completely non-absorbent, while being rigid and stable enough to withstand the force and heat of acceleration. And most importantly, will we be able to send image data back to Earth? It's a hard task. PhD positions are now open to find answers to all these questions. If we ever manage to do so, we will be probably able to send home images of the recently discovered exoplanet Proxima b and any other planets that may lie in the system. The future of interstellar exploration is bright, and the Starshot project could be the first step into a universe of possibilities. As you can see, the possibilities opened up by solar sail technology are vast and exciting. Solar sail propulsion has the potential to revolutionize exploration and expand humanity's understanding of the universe. In the future, solar sail propulsion could become the primary method of interstellar travel. Combined with other emerging space technologies, such as ion engines and nuclear reactors, it could enable us to explore the deepest reaches of the universe. That's all for this video. What do you think about solar sails? Let us know in the comments below. See you next time on the channel.